Welcome to Negative Exponents. The goal of this video is to simplify expressions involving negative exponents. When working with negative exponents, all of the basic exponent properties still apply, so we will be using all of these properties as we go through our examples. If you need to review these, you should watch the video entitled Properties of Exponents. So here are the properties of negative exponents. A to the power of negative n is equal to 1 over a to the power of positive n. So for example, if we have 3 raised to the power of negative 2, that would be equal to 1 over 3 to the positive 2 power, which would be 1/9. Now for me, it's often helpful to think of 3 to the power of negative 2 as a fraction where all of this is over 1. So if I move this across the fraction bar, it changes the sign of the exponent from a negative 2 to a positive 2. It's also true that a to the negative n power and a to the positive n power are reciprocals. Remember, if two terms are reciprocals, their product would be 1. And from what we learned in the previous video, if we're multiplying and the bases are the same, we add exponents. Well, negative n plus n would be 0, so a to the 0 power would equal 1, or from this definition we could rewrite a to the power of negative n as 1 over a to the power of n times a to the n. Again, this could be viewed as over 1, which simplifies nicely to equal 1. So whichever way you look at it, these two are reciprocals. The next property states a to the negative n divided by b to the negative m is equal to b to the positive m divided by a to the positive n. And this is kind of the idea I was alluding to above. If a factor is moved across the fraction bar, it will change the sign of the exponent. So notice how if this is moved up to the numerator, it becomes a positive m, and if this moves down to the denominator, it becomes a positive n power. Looking at a numerical example, if we had 2 to the power of negative 2 divided by 5 to the power of negative 2, if we move this up, it changes the sign of the exponent. If we move this down, it changes the sign of the exponent. So this would equal 5 to the positive 2 power, or 5 squared, over 2 squared, which would equal 25/4. And the last property of negative exponents, any base to an exponent is equal to the reciprocal of the base if raised to the opposite exponent. So notice how if we have a over b raised to the negative n power, that is equal to the reciprocal, or b over a, raised to the positive n power. So if we have 3/4 raised to the negative 2 power, that is the same as 4/3 raised to the positive 2 power, which would be 16/9. Now in my mind, this really is not a new rule because we know the exponent on this a is 1 and the exponent on the b is 1. So from the previous video, we know if we apply the power rule here, we would have a to the power of negative n over b to the power of negative n, which really brings us back to the previous rule where if we move these across the fraction bar, it changes the sign of the exponent. And if we wanted to, we could rewrite this as b over a raised to the n power. So all of these rules are closely related. But I would say the main rule you have to be aware of is if you move something across the fraction bar, it will change the sign of the exponent. So let's go ahead and apply these new rules with the basic properties of exponents. Here we want to simplify and write our answer without negative exponents. So here we're multiplying, our bases are the same, so the rule is we will add our exponents. That's the product rule over here on the right. So we'd have 2 raised to the power of negative 5 plus 2, which is equal to 2 to the power of negative 3, but we cannot have negative exponents in our answer. We could make this into a fraction by putting it over 1, so if we move this down to the denominator, it will equal 1 divided by 2 to the 3rd power, which would equal 1/8. For the next example, we're now dividing, so we'll apply the quotient rule where we subtract our exponents, and it's always the exponent of the numerator minus the exponent of the denominator. So this would equal x to the power of negative 4, but again, to have our answer with a positive exponent, we just need to move this down to the denominator, which would equal 1 over x to the 4th power. On our next example, all of this is being multiplied together, so 6 times 2, that would give us 12. M to the negative 4th times m to the negative 2. Again, we add our exponents to get m to the negative 6th power, and then n to the 6th times n to the 1st would equal n to the 7th. Again, I always find this helpful when I have a negative exponent to make it into a fraction. So in order to have a positive exponent here, we'll move the base of m down to the denominator. So we'll have 12 n to the 7th in the numerator and m to the 6th in the denominator. Here we apply the power rule. Well, negative 9 times negative 4 would be a positive 36, and that would be our final simplified answer. On this next problem, there's a lot going on, and I almost take a look at this and see 4 problems where we have the constants, we have the x's, we have the y's, and we have the z's, and they're all quotients. So we'll simplify each quotient separately and then combine them for our final answer. So negative 15/45 would equal negative 1/3. X to the negative 1 divided by x to the negative 4. Negative 1 minus negative 4 would give us x to the 3rd. Y to the 4th divided by y to the 1st. 4 minus 1 would give us y to the 3rd. And z to the negative 3 divided by z to the 2. Negative 3 minus 2 would be z to the negative 5th. So the only issue here is we cannot have z to the negative 5th in our simplified answer. Remember, if this was in fraction form, we'd have a denominator of 1. So we need to take this base and move it to the denominator. So our final fraction would be negative 1 times x cubed times y cubed, or just x cubed y cubed, over 3z to the 5th power. Okay, on this next problem, everything here is being multiplied together. So 6 times 2 would equal 12. M to the negative 4 times m to the negative 2. We're multiplying, so we add our exponents. This would be m to the negative 6. This is n to the 6th times n to the 1st. That would be n to the 7th. Again, if this is in fraction form, we'd have a 1 in the denominator. Therefore, to make this a positive exponent, we can move it across the fraction bar or down to the denominator, which would give us 12 n to the 7th divided by m to the 6th. Let's go ahead and take a look at 2 more. Here we have powers raised to powers, so we are going to multiply our exponents. This would be x to the negative 4 times 2, that's negative 8th, and y to the negative 3 times 2 would be negative 6th power. So now if we move this across the fraction bar and move this up, so we'd have y to the 6th in the numerator and x to the 8th in the denominator. Okay, we have one more. Now, there's quite a bit going on in this problem. Notice that we do have powers to powers, so we'll apply that rule first. So in our numerator, this would be a to the 2 times 3, or a to the 6th, times, here we'd have a to the negative 14th and b to the 7th. And in our denominator, we'd have a to the negative 1 times 2, a to the negative 2 power, b to the positive 2 power. Now we do have an option on what we want to do next. I would probably go ahead and multiply these two together. Remember, we multiply, we will add these exponents. We would obtain a to the negative 8th power, and everything else remains the same. So this next step, I'll look at this as 2 problems where we want to simplify the a's and then the b's by applying the quotient rule, where we subtract. So here we'd have a to the negative 8 minus negative 2. That would give us a negative 6. Next, we would have b to the 7 minus 2, which is b to the 5th. Again, we're not allowed to have negative exponents in our simplified answer, so we want to move this down to the denominator. So we have b to the 5th power over a to the 6th power. Okay, I hope you found this video helpful. Thank you for watching.